Okay, so we're going to pick up where we left off with the Slivka square. This is my second time through this. I will try to speak up. Um, we've got the Slivka square, this, square of things. There is not really any great foundations of the universe reason for this. It is strictly about the naming system. But the main pattern is when these form polyatomic ions, things inside the square, the 8 version is O4, the outside border, the 8 version is O3. So SO4 is sulfate, ClO3 is chlorate. Examples there. Now, key feature when you're kind of working out these polyatomic ions is that the charge is going to be the same as the monatomic. So sulfide is -2, sulfate is -2, sulfite is -2. Chloride is Cl minus, chlorate, ClO3 minus, chlorite, ClO2 minus. The two big exceptions there, and when I say big exceptions, if you've never heard of the 80-20 rule, it's something that exists in science, in language, in business, and oh my goodness, it's everywhere. But it's the concept that you use 20% of the knowledge 80% of the time. So if you want to learn a language, effectively you only have to learn 20% of the language because that will be 80% of what you ever use. So here we focus in on these. Are there other exceptions? Yes, thousands. But these are the extremely common ones. And you can be very effective just knowing the common ones, which is actually where this list comes from. Chlorate, nitrate, carbonate, phosphate, sulfate, those are nice and normal, but extremely common. Hydroxide, OH minus, we'll see that a lot. Ammonium, NH4 plus, our only positive polyatomic ion. And of course acetate, CH3COO with a -1 charge. Those are the ones that, as time progresses, you should be very fluent with. You shouldn't have to look them up. Now, the prefixes and suffixes, the hyper 8 is +1. 8 is our baseline. Ite is -1 oxygen. Hypoite is -2. Excuse me. And ide is the monatomic. Now, all of those do not always exist, but they start with the 8 and count off from there. Also, the hyper 8. I have never, in my entire existence, seen the HY actually attached. Officially, that is the name, hyper 8. It is above 8, as opposed to hypoite, below ite. So that is always shortened to just perchlorate, perbromate, periodate. Now, the ite, -1 oxygen from the 8, and hypoite, -2. Now, if you have something like sulfate, that's SO4, sulfite is SO3. Again, we're just counting away from the 8. And of course, the monatomic. Now, you notice these are all different by just a couple of letters. In some cases, like chloride, chlorite, chlorate, one letter difference. So, be on the ball. Now, we're talking about polyatomic ions. polyatomic ions are a group or a cluster of atoms that are covalently bonded together. They form their own unit and collectively have a charge. Individually, they have no charge, but they function as one unit, the same as any other charged particle. So I want you to take a moment, pause for a second, work through these. When you're done, come on back. So sodium sulfate, calcium carbonate, lithium nitrate, and, oh, look at that, copper 1 sulfite. Copper can have more than one charge. We have to say which one it is. So this is copper with a +1 charge, sulfite. Now, what I want you to do is try to write the balanced formulas for this. And yes, the last one, I am messing with you. Take your best shot at it. Write in pencil. So take a minute. Start again when you're back. Welcome back. Now we've got sodium. We've got carbonate. Carbonate is -2. Sodium is +1. First column. So it's going to take 2. We have cesium. We have nitride. And that is N-3. Cesium is +1. So there's 3. Notice no polyatomics in that one. It's not required. Barium nitrate. So barium is +2, second column. Nitrate, NO3 -1. So we're going to need 2 of them. And last, quite possibly least, we have ammonium. There's NH4, similar to ammonia, and peroxydisulfate. Now, in no universe are you going to be expected to have memorized that. But if we need to, we can kind of make some sense out of it. So disulfate, okay, S2. Now, 8, okay, and in this case, peroxy. So we know we're going to have a bunch of oxygens. Now, would I be expecting you to get 2 sulfurs and 8 oxygens out of that? 2 sulfurs maybe. 8 oxygens would be impressive. But notice the charge still carries through. Peroxydisulfate is still a -2. Sulfide is -2. Sulfate is -2. So even when we chuck in another sulfur, it's still -2. So without looking, take your best shot at these polyatomic ions. Pause, come back. Welcome back. We've got ammonia, our only positive polyatomic ion, our only common one. Sulfite, the SO4 minus an oxygen. Bromate, outside the line, so it's O3. Periodate. We start with the iodate, IO3, and add 1. Permanganate. Wait a second, that's way off the reservation. So here, manganate, Mn, it's outside, so that'd be MnO3, and it's got an extra, so MnO4. Now, the -1 charge, yeah, good luck with that. That is one, when we get to oxidation reduction, we'll see a lot. You might end up with that one memorized. It's not as important. Hypophosphite. Start with the PO4 phosphate. Knock off 1 for phosphite. Knock off 2 for hypophosphate. And the last one, bicarbonate. Bi means hydrogen. Not di means two, bi means hydrogen. So bicarbonate is hydrogen and carbonate. Carbonate is -2, hydrogen is +1. You can think about them as a single -1 unit, or you can think about them separately. Now, this is the slightly older name. I still like it. I still use it. It's still around a lot. But more and more, this would actually be called hydrogen carbonate as opposed to bicarbonate. All right, looks good. Now, again, pause, try these, circle back. Welcome back. Potassium sulfate, calcium chloride, silver selenate, selenium, and it's going to be inside the square, so it's O4. Selenide is -2, so this is -2. Now silver is +1. All right, next one, iron 3 nitrate, beryllium iodate, barium hydroxide, the OH, and yeah, I'm messing with you again. Now, we do have manganese. This one is manganese 2, but tetraborate. So B4, okay, tetra, 4. Borate, yeah, good luck with that. So this is another one I would not expect you to know. But you can kind of get an idea of what's there. Now the last one has two perfectly acceptable names that are two very different materials. You would need more information to know which one it was. Now, one name, just kind of playing it straight, we have palladium 4 oxide. So we have two oxygens. Oxygen is -2, so the palladium must be 4. The other option is that is O2. That is peroxide. Excuse me. That is peroxide. Now, peroxide is O2 with a -2 charge. So that would be palladium 2 peroxide. Now, covalent compounds, we're going to hit this at a run. Here we have nonmetal, nonmetal. They're sharing electrons. There are no charges. Don't get into the whole, but wait, they're both negative. How can I? No, you can't. And they're not. They're neutral. Because they haven't transferred electrons, they're sharing electrons. Now, because we have no charges to work with, we just name them with what's in them. So mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Now, 3 examples that tell us everything we need to know. The first one, we have dicarbon tetrafluoride. 2 carbons, 4 fluorines. Notice we changed the ending and only the ending to -ide. Next one is the first, the second compound, I guess you probably ever learned, carbon dioxide. Notice we dropped the mono at the beginning. The mono is very typical, I guess you could say. A great many molecular compounds, the formula starts with one of something. So monocarbon dioxide. No, we're just going to say carbon dioxide. We will assume the mono if you don't say anything different. Now it's only at the beginning. And then silicon tetriiodide. Little glitch there. Notice it is not tetraiodide, it's just tetriiodide. So, try these and come back. Welcome back. So, carbon monoxide, boron trifluoride, dinitrogen pentoxide. Nitrogen monoxide. Notice you can't drop mono in the beginning or in the middle. Fluorine monochloride. Iodine pentafluoride. Tetraphosphorus hexoxide. It's as complicated as they'll get here. And the last one, dihydrogen monoxide or water. If you really, really want to, you can call it dihydrogen monoxide. Nobody does that. Okay, there's one guy that does that and no one likes him. Just call it water. Which actually brings us to these common names. If we were doing this 20 years ago, I'd have about 20 of these names. If we were doing this 70 years ago, I'd have about 3 pages. These are names. They are not the scientific name that you can work out the contents. They're just the common name. They're a name that is so well known, it is used in place of the official scientific name. So water is the obvious example. There is no reason to say dihydrogen monoxide, except if you're being a pretentious dork. Ammonia, the next one, also extremely common. We're going to run into that one a lot. Notice it is the first cousin of ammonium, NH4+. If you add a loose hydrogen to ammonia, you get ammonium. You take a loose hydrogen from ammonia, or from ammonium, you get ammonia. Now the next one's a little weird because it is the official name. It's just a little hard to work out cold, because is it dihydrogen dioxide? No, that's peroxide. Those 2 oxygens, instead of being 2 oxygens, are bonded together as a peroxide. And with that one, it's O2 with a collective -2. Now, the next one, milk of magnesia. This is something they make a lot in Myerstown at Bear. They market it under Phillips blue bottle. This is something that back in the day when there was only like 5 items, 3 for cleaning, 2 for medicine, this was very popular because the hydroxide part of it is an effective antacid. The magnesium part is a very effective laxative. So multi-use product, you just have to really watch the dosing. Now the next one's sodium bicarbonate, aka baking soda, and hydrogen hypochlorite. The hypochlorite especially is the bleach. All right, last thing, acids and bases. Bases, well, we'll get to the definitions here. Acids are what's known as a proton donor. They put free hydrogen ion in solution. Variety of methods. Bases are a proton acceptor. They pull free hydrogen out of solution, and the effect is you end up with free hydroxide in solution. And we'll look at the mechanisms for how this works from the simple to the very complex. But with these, we're going to look at a couple of quick examples and then the naming system. So if I have an acid for our purposes has to have hydrogen in it. That's a little bit of a lie. Some types of acids don't need the hydrogen, but that's a very small sliver. That's a special case we'll get into. But if you notice the hydrogen is at the beginning, that is an indicator that that is likely an acid. I say likely because it is absolutely not a hard and fast rule. Now, classic bases have the hydroxide. it's easier to put hydroxide in solution if you bring your own hydroxide to the party. There are many other ways to generate hydroxide. We'll get into that. Now, in terms of the naming, the bases, we don't do anything special. They just get named as they are. So, sodium hydroxide, calcium hydroxide, get the idea. Acids, we break into two categories. We have binary acids. This is hydrogen and one single element. And we start with hydro, we end with ic acid. So that's not right. Okay, flip those two. Hydrochloric acid, hydrobromic acid. Try the last one. Pause for a second. Looking back. And here we have hydrosulfic, or if you had hydrosulfuric, that is perfectly fine. Notice you don't have to say dihydro or anything like that. It's just a compound with some loose hydrogen. Now, the ternary acids, these are the ones that have hydrogen and a polyatomic ion. What we do is we don't use hydro. That is the big difference. And we keep the stem name. Now, from there, the polyatomic ions, if it ends in ate, it becomes ic acid. If it ends in ite, it becomes us acid. So here we have nitric acid, nitrous acid.
Yeah, open windows.
And the last one, sulfuric acid. So that is sulfate becomes sulfuric. As we put the syllable back, nitrite becomes nitrous, nitrate becomes nitric. Now, that is as far as we're going to take things today. Organic compounds we'll get into tomorrow because they go crazy fast. There should be an assignment in Schoology. I should have that up and running by class. So after you've run through this and filled it out, do that, and we'll pick up there tomorrow. You can see grades. I've got a bunch of your stuff graded, but it's here. So there's that. All right. See you tomorrow. Bye-bye.